Hey everyone, thank you for joining us for the 2022 Google Data Cloud Summit. I'm Andy Goodmans, General Manager and VP of Engineering for Databases at Cloud. I'll be joined in this session by Bala Natarajan, Senior Director, Data Infrastructure and Cloud Engineering at PayPal. This session will cover some exciting new product announcements, some of our recent innovations, and our key focus areas for Google Cloud Databases. Google Cloud Databases are proven to run planet-scale workloads, from the most demanding workloads of our enterprise customers to Google services with more than 1 billion users around the globe. To give you a sense for the scale at which our databases operate, Spanner processes over 2 billion requests per second at peak. This is unheard of for a relational database service. Bigtable, our fully managed NoSQL database, processes over 5 billion requests per second at peak. Firestore is our serverless, mobile-optimized document database, powering applications with more than 750 million monthly active users. So this demonstrates the scale of the workloads that our databases support. Our databases help our customers modernize their apps and unlock the value of their data across the GCP ecosystem. For example, more than 650,000 Google Kubernetes Engine pods connect to Cloud SQL, and BigQuery users query over 125 petabytes of data in Cloud SQL on average per month. We offer best-in-class databases for always-on applications with global reach and unlimited scale. Google Cloud is committed to open source and open standards. We offer managed services that are fully compatible with the most popular open source engines such as MySQL, Postgres, and Redis, or third-party proprietary databases such as Oracle and SQL Server. We manage the complexity of running your databases so that they are simple to use and operate and make application development faster and easier for you. Leading organizations in all regions and industries have placed their trust in our databases. And our databases remain one of the fastest growing segments of Google Cloud. The reason for this strong adoption is that we have a relentless focus on addressing enterprise customer needs. Key areas you have told us you really care about: reliability and availability, security and governance, observability so engineers can self-help and root cause efficiently, making migrations easier and efficient, pre-integrating with other services such as analytics and AI and ML, so you don't have to take care of the plumbing yourself. Lastly, continuing to help you better govern spend and make continuous improvements in price performance. I will briefly walk you through each of these areas and provide you an update on the progress we have made in each. For reliability and availability, our transformative databases, Spanner, Bigtable, and Firestore, offer an industry-leading availability SLA of 5 nines. They also offer automatic sharding, zero-touch global replication, and no maintenance downtime. Cloud SQL maintenance is on average 80% shorter than it was 12 months ago. In fact, Cloud SQL's average maintenance downtime is now shorter than that of Amazon RDS and Azure databases, according to figures published in online documentation as of August 2021. Coupled with controls such as maintenance denied period and advanced notification, Cloud SQL is an industry leader in this space. With the recent addition of SQL Server cross-region replicas, Cloud SQL provides customers with multi-region scalability and disaster recovery options. For security and governance, we have standardized authentication and authorization in databases with IAM. For Cloud SQL for SQL Server, we've enabled cross-project integration to authenticate via managed Microsoft Active Directory. We continue to invest in more rigorous controls, such as customer-managed encryption keys, which provides customers complete encryption control of instance data and backups, as well as the ability to rotate keys on their own schedule. Security and governance is a huge focus area for us. For highly integrated, customers asked us for a solution to replicate and synchronize data across heterogeneous databases and applications in order to support real-time analytics, database replication, and event-driven architectures. Datastream is a serverless change data capture service which became generally available late last year. With Datastream, you can easily and seamlessly deliver change data streams from your Oracle and MySQL databases into Google Cloud services such as BigQuery, Cloud SQL, Google Cloud Storage, and Spanner. And today we are thrilled to announce that Spanner Change Streams is coming this quarter. Spanner Change Streams enable Spanner customers to track changes within their databases based on a defined scope and to easily access and integrate this data with other systems. With, with Spanner Change Streams, you can track changes on an entire database, a set of tables, or a set of columns in a database. This means customers can easily replicate database changes to BigQuery for analytics, trigger downstream application behavior from changes to the database, or capture database changes for archival or long-term storage purposes. Now let's see a short demo of Spanner Change Streams.
In today's demo, we'll look at a sample inventory application powered by Cloud Spanner and see how Change Streams allows you to seamlessly stream that data to BigQuery in near real time. Let's start by looking at the demo environment. As customers purchase items and inventory status changes in Spanner, the application inserts into this inventory ledger table. Our goal is to replicate these changes over to BigQuery for analytics. So let's go ahead and create a change stream. Creating a change stream is super easy. You just use DDL. That means all your existing workflows are supported. This change stream will track all changes in the inventory ledger table in Spanner so that we can stream those out to BigQuery. With a retention period of 1 to 7 days, you are in control of how long the changes are being kept in the stream. In this environment, there's already a high QPS workload on the inventory database. Let's manually insert a row into the table here. To simulate a restock of 500 avocados, we will follow along these avocados on their journey to BigQuery. To read and process changes out of change streams, you can use one of the Google provided open source data flow connectors, create your own connector based on our sample code, or use the underlying APIs directly. You have the full flexibility. For this demo, we've already deployed a pipeline based on our turnkey Spanner to BigQuery data flow template. Over in BigQuery, we can see that the connector has already replicated the relevant schema from Spanner and has streamed the changes into the corresponding table. So let's find our 500 avocados that we added to the inventory in Spanner earlier. Oh, look, there they are. Change Streams has streamed out the changes and the data is already available in BigQuery. With Change Streams, your Spanner data follows you wherever you need it at scale, whether it's for analytics with BigQuery, to trigger downstream applications, or for compliance and archiving use cases. Thank you, and back to Andy.
Wow, that was an awesome demo. I'm so excited about Spanner Change Streams. For financial governance, we believe that getting the best price in the cloud shouldn't require sophisticated forecasting models. Our committed use discounts reward your steady state, predictable usage in a way that's easy to use and can accommodate changes in your database environment. These committed use discounts are flexible. No upfront payments are required. These are available for and shared between MySQL, Postgres, and SQL Server instances, and they're fully transferable between machine sizes. So really the most flexible committed use discounts. We recently launched Bigtable Autoscaling, so you can automatically add or remove capacity in response to changing demands of your workloads, and only pay for the capacity you need. It also reduces your management overhead, so you can spend more time on your business and less time managing your infrastructure. We recently introduced Cloud SQL Cost Recommenders with Active Assist that empowers developers to better manage costs. It helps you detect idle instances, right-size over-provisioned instances, and leverage committed use discounts. So we are truly doing everything to make Cloud SQL and your experience with GCP more affordable. As wonderful and unique as Spanner is, it wasn't the most accessible database for developers. We wanted developers to be able to start small so they could design their applications for success from the get-go. To this end, we recently introduced more granular instance sizing for Spanner to democratize access to it. With more granular instance sizing, you can start at a tenth of the cost of a regular instance equating to approximately $65 per month. This means you can start small and easily scale your Spanner instance as your workload grows with no downtime. We recently also announced the launch of committed use discounts for Spanner to further reduce costs for customers committing to Spanner. You can get up to 40% discount on Spanner compute capacity by purchasing committed use discounts. Spanner committed use discounts are available now and are applicable for all Spanner instance configurations in all regions. For observability, last year we launched industry-leading observability with Cloud SQL Insights for Postgres. This has become one of the fastest adopted new capabilities for Cloud SQL. And you've asked us to deliver equivalent functionality for MySQL. Well, I'm thrilled to announce today the preview of Cloud SQL Insights for MySQL. Cloud SQL Insights empowers developers to address database performance issues themselves at no additional cost. Now let's take a look at a short demo of Cloud SQL Insights for MySQL.
Let's look at how I can use Query Insights to identify and diagnose a MySQL database performance problem in an application. Insights helps me investigate and detect problematic queries, find the root cause of the problem, and find the source in a single interface. Looking at the top-level Query Insights dashboard, let's start with the Database Load All Queries graph, which can help me visually identify performance problems or spikes in database load. The database load graph confirms there's a problem that started happening around 12 o'clock. The colors in the graph help me see that there's an increase in CPU weight and an even larger increase in lock weight. To try to identify which query is causing the problem, I'll start with the queries table, which contains normalized queries for the time frame selected. The first query in the table certainly stands out, as its total execution time is much larger than the rest of the entries. Now that I've identified that this is likely the slow query, I want to find out why. I'm going to click through to see more details for this query. Query plans can be complex and difficult to understand, but Insights provides visual query plans that can help me easily detect which part of the query is slow. Insights also provides in-context visualization of end-to-end tracing to help me find which application code caused the problem. Like many modern applications, this app consists of several microservices, and I want to know which one is causing the performance problem. Traditional monitoring tools only provide a query-centric view of performance. The tags table is especially helpful to me as a developer, since this application was built using an ORM rather than by writing the SQL queries directly. The first entry for the payment charge controller and the demo charge route looks like it's the problem. With this context, I can go look at the source code now to investigate further. Enabling Query Insights for Cloud SQL instances is quick and easy, and once enabled, it's always on, giving you access to a rolling 7 days of telemetry at no additional cost.
Wow, what an awesome demo. I'm really excited about Cloud SQL Insights for MySQL. For migrations, we've made migrations to Cloud SQL easy and fast with Database Migration Service. This offers a simple experience with minimal downtime for reliable and predictable migrations to Cloud SQL. It is serverless, secure, and offered at no additional charge. More than 85% of all migrations are underway in under an hour, and a majority of customers are migrating databases from other clouds. Database Migration Service supports MySQL and Postgres, with support for SQL Server migrations coming soon. Our customers want to modernize their Oracle databases to Cloud SQL for Postgres. And today, we are pleased to announce that Database Migration Service now supports Oracle to Postgres, schema, and data migration. This is available now in preview and offers a simple migration path from Oracle to Postgres. Database Migration Service integrates with the Ora2PG open source tool for schema conversion and provides serverless data movement and monitoring for your migrations. With this, you can reduce your costs and dependence on proprietary Oracle databases. Today, we're announcing that live migrations from Apache HBase to Cloud Bigtable is generally available. Bigtable is HBase API compatible and is a popular choice for customers to modernize their HBase clusters for better performance, scale, manageability, and cost savings. We have released features for live migrations, including a schema translation tool, replication library, and migration validation tool with the aim to make HBase to Bigtable migrations easier and faster for you. We know that migrations can be challenging. Therefore, we have invested in a comprehensive end-to-end program to help make your migrations experience fast, easy, and cost-effective. We do this by providing tooling and resources for assessments, project planning, and implementation. These efforts are further amplified with incentive funding designed to reduce the cost of your migration. Take advantage of this program and offer by getting in touch with your account team today. With that, I'd like to invite a customer who is driving data-powered innovation across their enterprise. We're fortunate to have Bala Natarajan from PayPal with us. Bala is the Senior Director for Data Infrastructure and Cloud Engineering at PayPal. Welcome, Bala.
Thank you. Thank you, Andy.
Bala, can you share PayPal's data journey with Google Cloud?
Sure, Andy. Thank you very much. PayPal, like many organizations, has become a data-driven organization. Many of our business users depend on data for their business-critical functions, including our CEO. When we looked at data lifecycle at PayPal a couple of years back, we observed that our business would benefit a lot by leveraging the cloud. Given the size of the ecosystem, we decided to slice and dice the approach to migrating to cloud. As a first step in the journey, we tried to take critical applications that were dependent on deep storage systems to GCP. This led us to adopt capabilities like BigQuery, cloud storage, PubSub, and Dataproc. Our users got a full view of the capabilities of the cloud. They were clearly able to understand the interaction models, tools associated, how to debug their systems, and the cost associated with their actions. Teams who were managing on-prem systems educated themselves on their role in the new model. With this experiences behind us, we are now taking the next step in the journey to migrate our transactional processing system to the public cloud. This involves looking at all the applications that are receiving payments, onboarding users, settlement systems with our third-party vendors. All of them we plan to migrate to the cloud. We are excited about this journey. Our pre-work in evaluating some of the capabilities from GCP is very, very encouraging. We have narrowed down the offerings that we plan to use to migrate these systems over to the cloud, Andy.
So as a large and sophisticated enterprise like yours, you must have many different challenges with your existing transactional and OLTP systems, between custom solutions you've built on proprietary systems to various open source databases. Help us understand how you're thinking of leveraging our different managed services like Cloud SQL, Cloud Spanner, as you migrate and transform your workloads to the cloud.
Thank you very much, Andy. This is a great question. You're spot on that we have incredible diversity in our workloads that are sensitive. Some of them are sensitive to the site, and some of them are very mission critical that deals with money movement as well as settlement. We appreciate and love the ability and the flexibility to pick the right databases for each of these workloads that we have. The overarching theme here, Andy, is to leverage GCP's managed services as much as possible. Using managed DBs reduces our maintenance burden, reduces our toil on the teams to patch, to upgrade system, recycle hardware, or plan our data center. Based on our analysis, we have rationalized to 4 different swim lanes on how we are going to approach this problem. The first swim lane targets application that makes changes to use capabilities of GCP instead of using a traditional OLTP system. We have a bunch of examples where we landed up using OLTP infrastructure since we could not get access to anything different a few years back. GCP helps us with new capabilities where we can make a switch now and is also portable across our systems. Some of our batch processing and reporting workloads potentially fit under the swim lane. The second swim lane, Andy, consists of redoing applications or developing new products or applications that would benefit adopting open standards and tools. For example, GCP's commitment to Postgres is something we believe we can leverage heavily. This will help us and to build a set of application families to evolve on a robust foundation for a period of time. We are thinking about 4 to 5 years or the next 10 years as we migrate to GCP. The third swim lane, Andy, consists of applications that are critical for PayPal's payment processing and would benefit by usage of Spanner. The reliability and the cross-geo capabilities of Spanner is something we would like to leverage for a set of these critical applications, which require these capabilities so that they can scale across the ecosystem. The fourth swim lane, Andy, consists of applications that could be considered legacy and would need the same infrastructure to continue to run. For example, there are we have a lot of fleet in MySQL, and we plan to use Cloud SQL on top of MySQL to port these applications to the public cloud. And thanks, Andy, for asking these questions.
Lana, thanks so much for joining us today and sharing with us your story on how PayPal is transforming data in the cloud. Really looking forward to our continued partnership.
Thank you, Andy.
At the heart, Google is a data company. When it comes to managing data, we had to solve some of the most difficult problems. We reimagined databases and invented Spanner, a database that gives you the best of relational and non relational databases. Our databases benefit from disaggregated compute and storage and our privately owned global network to improve performance, scalability, security, and availability. What all this means is that when you adopt our cloud databases, you immediately benefit from our long-standing culture of excellence and innovation. With that, I'd like to thank you for joining Google Data Cloud Summit. We hope to partner with you to accelerate your data-driven business transformation. Thank you.